Hello, Cougars, and welcome to this weekly overview and agenda video for the week of 11/16. Couple quick notes before we jump into it. Progress report card should be coming out this week. Just know that anything that you have not finished from earlier in this quarter can still be completed for full credit. During the Thanksgiving break, starting next week, there will be no assignments given, so that might be a perfect time to catch up on any missing work, as well as finish your TED 2 and 3. Even if you don't turn it in, have it ready to turn in so that when you get some feedback on TED number 1, you can make some small adjustments and be ready to go on that. But take advantage of the week coming up to also not this week, but next week, to take some time to relax and enjoy your family and all that good stuff. But also, if you're behind, pull some of that work out and try to get caught up. Okay, so let's take a look at this week. So I will be posting the video link here like normal. On Monday, you're going to start off with taking some video notes on wave behaviors, and you're going to have a small worksheet working through those notes. So I would watch the video first. I would actually probably look at this document first, kind of see what's going to be asked of you. And then I would go through and I would watch the videos and take good notes and then come back and finish this document. On Tuesday, for blocks 1 and 2, we'll have our Zoom where we'll discuss these wave behaviors. And then you will have some time to work on a wave speed lab using a bar of chocolate and a microwave. I'll explain that more in just a second. On Wednesday, we will have video notes on the Doppler effect, and you will do another lab using the gizmos. We haven't done those in a little bit, but we'll log into gizmos and do a Doppler effect lab, which is really cool and very important. And then on Thursday, we will talk about the Doppler effect and its applications, why we use it and how we use it for all kinds of things. And then we'll have some time to work on our TED number 2 final draft, which is technically due this week by Friday. On Friday, you will have a waves test, because this will be the last week of waves. When we come back after Thanksgiving break, we will be starting electromagnetism and the atom. On this test, it'll be about wave behaviors and mostly vocabulary and stuff from last week. And then you'll finish up the week with your weekly reflection. And block 3 and block 4, there's actually not much of a change in the order of what you're going to be doing. So make sure that you're checking your agenda for your week. Okay, so the first assignment is to watch 3 sets of video notes. So all of these are done by Professor Dave, and they're really short and really quick, but they're really good and informative. When he has things like this, these questions, make sure you're writing those down and then writing down the answers to those questions for your notes. So basically what's on the slide over here is the stuff that you need to know. The good news is it's a 6-minute video, so it's pretty quick. There will be questions about noise canceling headsets, so make sure you're really paying attention to that. And then at the end, he has some fill in the blank answers. Make sure you also get that down. If you get that information down, then you will actually be pretty well prepared for the test at the end of the week, as well as the assignment. So he does one that's just on waves in general. Then he has one that's on light. And he talks about what light is, different parts of what light. And then there's some questions at the end. Just know that some of the light behaviors actually apply to sound as well. And we'll hopefully have a chance to get into that. So here is more about light, but this is more about how color and how we see color, how that all works with the principle of refraction and diffraction. Very interesting. And just keep in mind that I think he hits on it, the difference between color addition and subtraction in art versus how it works with waves in light. It is actually slightly different. So make sure you're paying attention to that. And so yeah, make sure you get your notes on that. And then there should be a red submit button, and then just submit your pictures like we always do. The next assignment, 5.2.2, wave behaviors and concepts. So these are basically questions based on the things you watch in these notes. The first part of this, though, is like a miniature lab. So if you click on this link and you go to this link, you see the physics classroom. And the first thing you should do is the directions are here. You can maximize the simulation by clicking in the upper left corner. So we go to the upper left corner and we click on that, and now the simulation is full screen, okay? Okay, so you can maximize it. You can minimize it by hitting escape. Across the top are buttons that run the simulation. Across the bottoms are buttons that change the media. And then we're going to set this up by showing the protractor, hide partial reflection, and click go. Then we're gonna move the crosshairs over the spot where the laser bends as it goes from one medium to the other. Okay, so let's go look at what I mean by all that. So we're gonna maximize our simulation. So we've got the buttons across the top. So we can click go, and this laser shoots a beam of light at the medium, and then something happens to the beam of light. So first thing we can do is then click clear, and we can change it. If we select other items here, we can click reset, and it resets it back to the original settings. Okay, so if I click show or hide partial reflection, what you will get is, see how that beam that we had a second ago, if I click this and then click go again, we get the beam partially reflect off the water. We're gonna actually hide that for now, okay? Because we're not interested in reflection, we're interested in how changing the medium. So up here at the top, we are in a vacuum, and then at the bottom, we are in water, it looks like. See how these are color coded? So if I do vacuum and click go, the laser should go in a straight line, and it does, okay? If I click vacuum and air, click go, there should only be a small change, if any, and don't really see the change. If I click water, then we should see the big change, okay? Oh, I have to hide the partial reflection. Okay, so now what I really want you to do though is you're gonna click show protractor, and then you can grab the protractor and hold it over where the light goes from one to the other, where the angle changes, and now you can measure that angle. So this line up here, let me get my writing tool here. This line right here is called the normal because it's perpendicular to the surface. So it's the normal. We call that the normal. It's a fancy math word for perpendicular. Okay. So refraction, the normal is on this side, and we're looking for this angle. So when I talk angles, the angle in the chart will be this angle, and then it will be, actually, no, wait, it's this angle versus this angle. Okay, so, and then we're going to play around with what angle is this and how does that change the angle down here. So let's go back to our table and let's take a look at what I'm actually talking about here. So here in the table, it says vacuum to water. We put 66 degrees, the refracted angle is 43, and is it toward or away from the normal? So let's go and take a look. So expand, and you know what? Here's what I'm gonna do. This will be easier if I do it this way. Okay, so now you can see more. So now what I would do is I would split screen it like this. You can split screen it. So 66 and 43. So laser angle is 66 degrees. All right, let's try this. So 66, so there's 60, there's 65. Oh, it was already at 66. Okay. And then the angle was 10, 20, 30, 43. So 1, 2, 3, that's kind of hard to see. Those are small lines. It's 43. And when I say away or towards the normal, what I mean is, so this is what it normally would be. But then when I change it to water, which way did the angle, yeah, you may have to, there we go. Which way did it go? So originally, this line kept going straight, but which way did it bend? It bent towards the normal, okay? So that actually is important, especially if you're designing lenses or designing things to look through things. We can actually bend the light a certain direction, so we're moving towards this normal. Okay, so if it was to go straight, which way did it go? It went towards normal. There are some situations where I'll actually go the other way, and you will see some of that as we try these out. All right, so let's go and switch tools and go back to our table. So the first one, vacuum to water. So I've got vacuum and I've got water, and I'm gonna set the laser at an angle of 30 degrees. So we'll do this first one together, and then you can do the rest on your own, I think. So we're gonna set this. So see, notice how I grabbed the little laser and put it right on the protractor so I can see I'm at 30 degrees here, okay? And now I'm gonna hit go. Clear my drawings. I hit go. So if this were to keep going straight, it would keep going like this. It would actually go to 30 degrees. Okay, if you're following your rules of geometry, that's exactly what would happen. Okay, but because it's changing what it's passing through, it causes the light to bend towards the normal, and it's at 20 degrees. So you can read it. It's 20 degrees there. So I'm going to go back to my document. And so this will be a reflected angle of 20 degrees, and it would be toward. Okay? And so then next, you're going to change the angle to 80. And then the next one, you're going to change it from vacuum to diamond. So we got to find diamond down here. And I believe that's diamond. And we see how it acts differently. Okay, so different substances cause different things to happen. Okay. Down here at the bottom, so you can fill out the rest. These two are just for you to play around with. So pick any angle that you want, and then record what the resultant angle is and whether it moves away or towards. Okay. Is there a medium and angle combination that only results in a reflection? So just remember, it's refracting if it passes through, but it bends. Okay. It's reflecting if it bounces back. So there's really small amount of reflection. We want it to where there is no refraction. It is all reflected. So what kind of angle might get you that? Okay. So that's for you to figure out and see if you can get one. Oh, wow. Almost. Still some refraction in there. So that's not quite it, but that's actually pretty good. Okay. So what angle can I get a pure reflection? You can try other substances and see what you get. Okay, the next part of this is just based on your notes. This is shown in the video, this kind of a drawing. You have a wave pulse going to the right, you have a wave pulse going to the left, they meet in the middle, and then they keep going afterwards. So what are those called? You're gonna mark those, and then you're gonna tell me how noise canceling headphones work. And then for this section on light, you're going to fill in the blank. You're going to go back to your video notes. There's a slide where he shows like 7 different technological uses of electromagnetic waves, and you're going to pick 2 of those and describe. What's the speed of light in a vacuum? And explain to me how we see color. And that will wrap up this document. Okay, so that's pretty much it for Monday. On Tuesday, we will have our Zoom of the week where we'll talk about those wave behaviors in more detail, review a couple things. Then you're going to have a wave speed lab. So this is a unique lab because it's designed to be a do-at-home lab, but you don't have to actually do it because we do it in the video for you. So if you are unable to do it, you can watch along and just follow along with the video. But you are certainly welcome to go and get a bar of chocolate and actually use your microwave at the home as long as you have permission from your parents and do the lab. So this video right here is done by Mr. Ness. So if you click on it, he's going to step through all the steps on how to do this. Okay. So one of the things I want to point out is there's parts of it where he's explaining where to look on your microwave to copy down important information. But if you can't do this, you don't have a microwave, or you're just not allowed to, or you can't get chocolate, whatever it is. If you can't do this, use his information that he has in his video. If you use the information he has in the video, he actually does it for you. He shows you how to do it. He also writes down the times and all the information for you, so you can copy down what he does to answer the lab. Okay. With that said, here is the lab document for you to use. So our standard deal, make sure you file, make a copy, and rename, but then go through and then you can follow his directions and answer those questions. Okay. And if you do it for yourself, that's great, or you can follow the information that he gives you. And I think you'll find it very fascinating. Basically, you're going to use a microwave and a bar of chocolate to find the speed of light. It's pretty crazy. Wednesday, you're going to have some video notes on the Doppler effect. So the first one is a crash course video on sound. They go pretty fast, so you may actually want to turn on the subtitles. I really like this because it talks a lot about sound as an application and how we use it. It talks about how your cell phone speakers work. It talks about how the wave is actually generated. It talks about volume, okay, which has to do with the amplitude as well as the intensity of the sound, okay? Don't get too wrapped up in the math because we're not going to really talk about this, although it is very fascinating. But this Doppler effect at the end applies to sound and light. But they have a really good couple of examples on what it looks like. And that's what probably the most important part of this video, honestly, is what the Doppler effect is. Please note that they do talk about what pitch is. That is a test question, hint, hint. So what part of a wave represents the pitch of a sound wave? When you finish that, there's a follow-on video that's specifically about Doppler effect. One, they have some really good animations of what it looks like, an explanation, but this is probably the one that's really important because the first video focuses on the Doppler effect as sound, and this is a perfect image, perfect, it might be too strong a word, but this is a great image of what the Doppler effect looks like for light. So we have a white light that's producing waves of light, but as it's moving towards an object, the light is shifted towards the blue color of light. And as it's moving away, so if I was standing back here and I see the light going away, I would see red light, something more red, okay? So that's a really cool visual of what's happening. And we use that to determine what stars are made out of, whether stars are coming towards us or away from us. It's a really, really good video to talk about stars and how we figure things out. So to follow that up, the next thing you're going to do is you're actually going to do a gizmo on the Doppler effect. So we're going to use this gizmo document like we have before. So make sure you file, make a copy first, and then make sure you put your name, change it, put your name. Okay, rename it, click OK, and now you've got it. The first part is more of a kind of what do you know? You play the sound button, and then you're going to see what you hear. You're going to actually use the ruler in the gizmo to measure the wavelength. And then you're actually going to really start manipulating the frequencies and playing with and see what the Doppler effect looks like. So the gizmo itself, it's been a while. So your login and password should be your school's login and password. You should have written it in your notes because I asked you to do that when we first signed in. But there are some of you who have never signed into a Gizmo, because you can access the Gizmo. It's quite challenging without logging in, but you can access it without logging in. But if you do log in, it makes your life much more easy. So make sure you log in. If you need help logging in, you need to come see me during tutorial time so I can get you sorted out. That's probably the best way to do it. So tutorial time on Tuesday would be excellent time to do that. We set you up with the account so you can get going. So when you log in, you'll go to your class and you will only see the Doppler shift. You'll click on that. And if you're searching for it because you can't log in, just search for Doppler shift. And here you go. So here's the sound. You can play this. So that's what the Doppler effect sounds like. It's coming towards you. Now it's going away from you. And you can answer questions. Basically, for the controls, you can click play and you see the car moving. Now the car is creating a sound wave as it moves. If it's a police car, it's got a siren or something, but even just by its motion, it's creating a sound wave. And you see the car moving and you see the wave that is generating. So we can play the observed frequency. So frequency is how many waves are in 1 second. So the observer, as it's moving towards you, is actually seeing more waves. And then as the car moves away, it takes longer for the wave to get to them, so they see fewer waves. Okay, and so you see the frequency drop. Okay, and we can use the ruler. So we can click play, we can drag the ruler, we can pause it, and we can actually measure the wavelength. Okay, so that's 400, that's 500 meters. So the wavelength here is 500 meters, and we can use that with our math. Down here, we can actually change the frequency. I actually have to reset. We can change the frequency of the source. So we only have 3 choices. We can change the speed of the source. Okay. And we can change the speed of sound. Now the speed of sound changes only with the change in a median, but its default is 340 meters per second. So we're pretty much just gonna leave it there. We can also help us when we're measuring by displaying additional waves. So basically what that's showing us is where the wave was through an interval of time, okay? But I think follow the directions in the gizmo. So make sure that when you play with the controls a little bit, but then come back and follow the directions. The directions are right here. Get the gizmo ready, click reset. Check that F source is set to 500 and V sound is set to 340. So let's click reset. 500 and 340, okay. Set the V of the source to 0. Okay, so I'm gonna set my V to 0. Okay, so just follow directions and then keep reading and then read what it says and do what it says. Eventually you will change those settings and you'll be able to finish the lab. All right. Okay, so that should be quick and easy. Hopefully you'll get to see what the Doppler effect looks like. And then on the following day, we will actually talk about some applications of the Doppler effect. We use it for radar. We use it for echolocation, sonograms. I mean, there's tons of application of the Doppler effect as well as astronomy, all kinds of stuff. So yes, we're going to talk about that on Thursday. On Friday, there will be the quiz or the test, which will mostly be vocabulary again, as well as asking questions about light, sound, reflection, refraction, and the Doppler effect. And then at the end, you have your weekly reflection. Some of you are having trouble inserting pictures into this. Make sure that you're going to File, Insert, inserting an image. Depending on the file type of your image, it may not like it, and so you're having trouble with that. Well, fill this out, submit, and then come back and resubmit and just put the pictures. Because I can see that you've submitted 2 things, and if I only see the pictures, I'll go look at the other submission and read the document. Okay. If I get the pictures first, then I'll go look, or I get the document for, I'll go look for the pictures. So that's probably the easiest way to fix that, is just do a resubmit and then add the pictures, because I can see both submissions. Okay. And the only other thing for this week is quarter project TED number 2, final draft, is due by Friday. Okay. So do your best to get that done. You will have some time on Thursday and Friday to work on that. We're not really doing a whole lot with the 7 steps, 7-step problems and that kind of a thing. So it will actually reduce the workload, but there is a lot of notes to kind of get through. So make sure you're staying on top of it, and coming to tutorial time if you need any help. That concludes this overview video for the week. I hope you have a great week.